Namaste everyone. In this video, we shall answer a question related to chemistry. This is part of chapter 1, chemical reactions and equations of class 10 CBSE. Before we answer this question, I have a request. I request you to contact this number 9742774659 through phone call or WhatsApp for online tuitions. Online tuitions will be done for individuals, or the online tuitions will be done for students in groups, individually or in groups. Subjects are math, physics and chemistry, classes 9th, 10th, 11th and 12th of CBSE as well as PUC, that is Karnataka State Board. Thank you. Now let's get back to the question. So in this question there is a substance which is blue in color. It's copper nitrate. So copper nitrate is taken in a boiling tube. Boiling tube is a special type of test tube made up of special type of material which does not crack when you supply sufficient heat or in a very high amount of heat to it. So boiling tube, as the name suggests, is a test tube that is used to heat a substance or heat substances. Now here the substance that needs to be heated as per the question is copper nitrate. Copper nitrate has the formula CuNO3 twice. Why 2 came here? If you observe, they have given the valency of copper as 2. Why should it be mentioned? Copper has 2 valencies, 1 and 2, cuprous and cupric. Here it's important to know whether it is cuprous or cupric. So it is cupric ion, meaning the valency of copper should be 2, and because the valency of copper is 2, 2 has come here. There is no number here, means 1. That is because of nitrate ion having valency 1. Now this is the chemical formula of copper nitrate. So when copper nitrate is heated, it forms copper oxide, which is black in color. They mentioned that. They say oxygen gas is formed, that's why O2, and a brown gas is formed. I am writing it as nitrogen dioxide now. Okay, we will answer how to confirm that gas is a nitrogen dioxide test. That we can answer as a part of the question B. Identify the brown gas X evolved. Now let's balance it. We have to write the balanced chemical equation for this reaction. That can be done if you know this gas other than oxygen. I have taken it as nitrogen dioxide, and we will see how it can be confirmed that the gas evolved along with oxygen is nitrogen dioxide a bit later. Now let's balance this. I am writing the CuNO3 twice as CuN2O6 just by multiplying 2 with 1 and 6. I have written CuN2O6, and I have written like this. I was about to balance, and then the video had to be stopped for some reason, so that's why I have partially balanced it. Let's continue this balancing process. Now the method which I will be using is hit and trial method. I've already used this method, hit and trial method, to balance two chemical equation in 2 of my previous YouTube videos. You will find the videos in my channel Vinayaka AV. You may please look into it. Now coming back to this balancing of this equation, so the element with the highest number of atoms is oxygen. In the reactant side it is 6. In the product side, before I had written 2, it will be 1 plus 2 plus 2, so it will be 5 in number. Now here it is 6, here in the product side it is 5. So it becomes difficult to balance when the numbers involved are even and odd. So let us make the number of oxygen atoms as even. That can be done by writing a 2 here. So 2 into 1, that is 2, plus 2 plus 2. So 2 plus 2 plus 2 will now become 6 after writing 2 here. The number of oxygen atoms in the product side is 6. In the reactant side is also 6. Next, let us choose nitrogen element for balancing. Why? Because it is the next highest number of atoms after oxygen. Nitrogen has 2 oxygen atoms in the reactant side. Here it is only 1. So how to make it 2? I'll write 2 over here. So nitrogen is balanced, but this will imbalance the number of oxygen atoms. Now the number of oxygen atoms in the product side is 2 plus 2 into 2, 4 plus 2, 2 plus 4 plus 2, 2 plus 4 plus 2 is 8. The number of oxygen atoms is 8 here. Here it is 6. So how to make it this one? This can be done by writing a 2 over here. So if you write 2 over here, here, what will be the number of oxygen atoms? Number of oxygen atoms will be 2 into 6, that is 12. The number of oxygen atoms will be 12, and here it will be 8. 2 plus 4 plus 2, it will be 8. So we have more number of oxygen atoms in the reactant side than in the product side. So we have to increase the number of oxygen atoms in the product side. How can that be done? Means I'll multiply this by 2. Why should I multiply this by 2? Why not this by 2 is, let's recount the number of oxygen atoms, rather nitrogen atoms after writing 2 here. Nitrogen atoms is 2 into 2, that is 4. 4 nitrogen atoms here, and here as you can see the number of nitrogen atoms is 2. How to make it 4 here? I will make this 2 as 4. I'll make this 2 as 4. Now the nitrogen atoms in the reactant side is 2 into 2, that is 4, and here it is 4 into 1, that is 4. So the nitrogen atoms are the nitrogen atoms are 4 in number in the product side as well as in the reactant side. Now let us recount the number of oxygen atoms. 2 into 6, it is 12. Here it is 2 plus 4 into 2, 8 plus 2, 2 plus 8, 2 plus 8, 10, 10 plus 2, 12. So the number of oxygen atoms is also balanced. Nitrogen is balanced. What is left out? Left out element is copper. Copper is 2 into 1, 2 in number here. It is 2 into 1, it is 2 in number here. So the number of copper atoms is also balanced on both sides of the equation. So the balanced chemical equation. So let us rewrite the balanced chemical equation for this. Let us rewrite the balanced chemical equation. So the balanced chemical equation is CuNO3 twice upon heating forms 2CuO plus 4NO2 plus O2. So this is the balanced chemical equation of the given reaction. So we have answered the first sub-question A, wherein we have to write the balanced chemical equation. Now let us answer the second sub-question. Identify the brown gas evolved. How do we identify the brown gas evolved? Actually the answer is the brown gas is nothing but nitrogen dioxide. Brown gas is nitrogen dioxide. How do you know that the gas is nitrogen dioxide? There are two types of tests called as preliminary tests and confirmatory tests. So preliminary test, so like it's brown color gas is nitrogen dioxide. One of the brown colored gas is nitrogen dioxide. One more test is there, which is again a preliminary test, which confirms that the gas is nitrogen dioxide. Is what we can do is we can take a moist blue litmus paper. So when this gas evolved in this reaction comes in contact with this moist blue litmus paper, it will turn red. Confirming that the gas is an acidic gas. And we know that the non-metallic oxides like nitrogen oxide or nitrogen dioxide, they are acidic in nature. So in this way we can confirm that the gas is nitrogen dioxide also. One more test is there, which is a confirmatory test. This test will confirm that the gas is nitrogen dioxide, not any other gas. How do you do that? Is this test tube in which the brown fumes are evolved, Okay, we need to place acidified ferrous sulfate piece of paper here, which is, this piece of paper is green in color because of this acidified ferrous sulfate present on it. It's green in color. When this gas, which is evolved in this reaction, comes in contact with this green colored acidified ferrous sulfate paper, it turns brown. The green color will turn to brown. In this way we can confirm that the gas in this reaction is nothing but nitrogen dioxide. Now identify the type of reaction. Let's look at the balanced chemical equation. There is only one reactant. This reactant splits itself using or absorbing the heat energy. It will decompose itself by absorbing the heat energy to form three products. We know that a reaction in which a single reactant breaks to form two or more products is called decomposition reaction. And if heat is used, or if heat energy is used by the reactant to decompose to form two or more products, such a decomposition reaction is called as thermal decomposition reaction. So identify the type of reaction. It is thermal decomposition reaction. That's the answer to the question C. What could be the pH range of aqueous solution of the gas X? I have already discussed this here while discussing about preliminary tests for testing nitrogen dioxide. I said that if you take moist blue litmus paper and bring it near the mouth of the test tube, and once this moist blue litmus paper comes in contact with the gas evolved, it will turn red. So we know that acidic substances can turn blue litmus to red color. So this confirms that the gas is acidic in nature, and its aqueous solution will be acidic. In nature. And pH for acidic substances will have a range less than 7. So pH will be less than 7 for the aqueous solutions of acidic gas. So what is the answer? What could be the pH range? The answer is pH is less than 7. We have answered all the 4 sub questions given in this question. Thank you for watching. Please subscribe, like and share. Thank you again.